So in this session, I am going to explain S matrix representation of multiport network of module 2 for microwaves and antenna subject. It covers the course outcome CO2. And in this session, I am going to explain the S matrix representation of multiport network and the two-port network theory and the different types of losses and properties of S matrix and some questionnaires. Then first I am going to explain the S matrix representation of multiport network. So the figure shows the junction of n number of waveguides. So that is consider n number of rectangular waveguides. In this case, all A's, that is small a's, represent the incident waves at the respective ports. Then all B's represent the reflected waves from the microwave junction that is coming out of respective ports. In this case are still valid where Sij and Sii. The Sij and Sii having the for meanings, that is Sij is equal to scattering coefficient corresponding to the input power applied at the ith port and the output power coming out of jth port, and Sii equal to scattering coefficient corresponding to the power applied at the ith port and output taken out of ith port itself. This coefficient is a measure of amount of mismatch between the ith port and the junction. Then coming to the two-port network. So in this two-port network, it's a 4-terminal device at the input port and the output port. So input port, consider it is a voltage V1, and the output port consider voltage is V2, and the input current you have to consider I1 and the output current you have to consider I2. Instead of A and B have to consider the A and the B's. So that is A is represent the incident waves at the respective ports, and B's represent the reflected waves from the microwave junction coming out of the respective ports. So by using this two-port network, the S matrix, that is scattering matrix, can be written as B1 of 0 is equal to S11 of A1 of 0 plus S12 A2 of 0, and B2 of 0 is equal to S21 A1 of 0 plus S22 A2 of 0. It can be written in terms of matrix form, that is B1 of 0 and B2 of 0 equal to S11 S12 S21 S22 in the matrix form, that is multiply with A1 of 0 and A2 of 0. In short form, that is B is equal to S into A. So this S11 S12 S21 and S22 are S, that value is called as scattering matrix. Then the scattering parameters. So in the equation we have to consider A2 equal to 0 and A1 is equal to 0 for finding the values of S parameters S11, S12, S21 and the S22. In order to calculate S11, we have to consider A2 is equal to 0. If A2 is equal to 0, then we will get S11 is equal to B1 of 0 divided by A1 of 0. That is called as output is matched, and the input reflection coefficient with output matched A2 equal to 0. Then in order to calculate S12, we have to consider A1 is equal to 0. If A1 is equal to 0, then S12 is equal to B1 of 0 divided by A2 of 0. That is input is matched. So there is a reverse transmission coefficient with the input matched. A1 is equal to 0. Then in order to calculate S21, we have to consider A2 is equal to 0. If A2 is equal to 0, then S21 is equal to B2 of 0 divided by A1 of 0. That is output is matched, and the forward transmission coefficient with respect to with output matched. Then S22, for calculating S22 we have to consider A1 is equal to 0. Then if A1 is equal to 0, then S22 is equal to B2 of 0 divided by A2 of 0. That is input is matched. So the output reflection coefficient with the input matched. In general multiport network, that is Sij is equal to Bi of 0 divided by Aj of 0 and Ak equal to 0 and K is not equal to J. That is, all ports except J are semi-infinite or matched. Then in this case we are using the different types of losses. For explaining the losses, we should know the input power and the output power. So consider Pi for incident power at the port 1 and P0 output power at port 1. So PR is equal to power reflected by the network. So the different types of losses are total 4 losses are there: the insertion loss, transmission loss, reflection loss and the return loss. So first we'll discuss about the insertion loss. So insertion loss can be defined in terms of dB, that is 10 log to the base 10 Pi divided by P0. But we know that the Pi is directly proportional to the mod of A1 whole square and P0 is directly proportional to the mod of B2 whole square. So Pi divided by P0 is equal to mod of A1 square divided by mod of A2 square equal to 1 divided by mod of B2 by A1 whole square. So mod of B2 by A1 is nothing but what? That is a scattering matrix S21. So 1 divided by mod of S21 whole square, that is equal to 1 divided by mod of S12 whole square. So substituting this equation 3 in equation 2, we get the insertion loss in dB, that is 10 log to the base 10 1 divided by mod of S21 whole square, or in terms of dB we can write it as 20 log to the base 10 1 divided by mod of S21, or that value is equal to 20 log to the base 10 1 divided by mod of S12. Then second one is transmission loss. The transmission loss can be defined in terms of dB, that is 10 log to the base 10 Pi minus Pr divided by P0. So where Pi is nothing but incident power, Pr is nothing but reflected power from the network and P0 is the output power. So this can also be written as 10 log to the base 10 mod of A1 whole square minus mod of B1 whole square divided by mod of B2 whole square. So here 10 log to the base 10, that is A1 mod of A1 whole square minus mod of B1 whole square divided by B2 square whole divided by B2 square divided by mod of B2 square divided by mod of A1 square, that is equal to 10 log to the base 10 1 minus of B1 whole mod of B1 whole square divided by mod of A1 whole square whole divided by mod of B2 whole square divided by mod of A1 whole square. So mod of B1 whole square divided by mod of A1 whole square, that is nothing but B1 by A1, that value is S11, and B2 by A1, that is value is S21 for the S parameters. So the transmission loss in terms of dB, we can write it as 10 log to the base 10 1 minus mod of S11 whole square divided by mod of S21 whole square. Then third one is reflection loss. The reflection loss in terms of dB, that is defined as 10 log to the base 10 Pi divided by Pi minus Pr. So the 10 log to the base 10 Pi, that is the input power, and the Pr is the reflected power, that is a mod of A1 square divided by mod of A1 square minus mod of B1 square. So 10 log to the base 10 1 divided by 1 minus mod of B1 square divided by mod of A1 square. So B1 divided by A1 is nothing but S11 in the S parameters. So the reflection loss in terms of dB, we can write it as 10 log to the base 10 1 divided by 1 minus mod of S11 whole square. Then last one is return loss. So return loss in terms of dB, it is defined as 10 log to the base 10 Pi divided by Pr, where Pi is the incident power and Pr is the reflected power from the network. So it can be written as 10 log to the base 10 mod of A1 square divided by mod of B1 square. So 10 log to the base 10 1 divided by mod of S11 whole square. So the S11 whole square. So in terms of dB, it can also call it as, write it as, that is 20 log to the base 10 1 divided by mod S11. Then coming to the last topic, that is properties of S matrix. So here it is a property 1. When any ith port is perfectly matched to the junction, then there are no reflections from the port. Thus Sii equal to 0. If all the ports are perfectly matched, then the leading diagonal elements will all be 0. This is a property of 1. Then property 2, that is symmetry property for S matrix. If a microwave junction satisfies the reciprocity condition and if there are no active services, then the S parameters are equal to their corresponding transposes. So that is nothing but Sij is equal to Sji. Then property 3, that is unitary property or lossless junction. Unitary property for a lossless junction. This property states that for any lossless network, the sum of the products of each term of any one row or any one column of the S matrix with its complex conjugate is unity. Then summation k is equal to 1 to n Ski multiply with the conjugate of Ski equal to delta of Ij for all I and j, where delta Ij is equal to 1 if I is equal to j, delta Ij equal to 0 if I is not equal to j. When I is equal to j, then the equation summation k is equal to 1 to n Ski complex conjugate of Ski multiply equal to 1, that is called as unity property. And I is equal to j, then summation k is equal to 1 to n Ski multiply with conjugate of Skj, that value is equal to 0, that is called as 0 property. Then property 4, that is phase shift property. The complex S parameters of the network are defined with respect to the positions of the port or reference planes. For a two-port network with the uniprimed reference planes 1 and 2, the S parameters have definite complex values. When the reference values 1 and 2 are shifted outwards to 1 dash and 2 dash by electrical phase shift of phi 1 is equal to beta 1 into L1 and phi 2 is equal to beta 2 into L2 respectively. Then the new wave variables are A1, e to the power of j phi 1, B1 e to the power of minus j phi 1, A2 e to the power of j phi 2, B2 e to the power of minus j phi 2. For new S matrix is then given by S dash is equal to matrix of e to the power of minus j psi 1 0, 0 e to the power of minus j psi 1 psi 2 multiply with S matrix with the another matrix, that is e to the power of minus j psi 1 0, 0 e to the power of minus j psi 2. Then some of the questions for this session, that is explain briefly the S matrix representation of multi-port network, and second one is they explain the various losses expressed in terms of S parameters, and the last one is explain the properties of the S matrix. These are the descriptive questions for the topic. Then some of the multiple choice questions are first one, that is S parameters are expressed as the ratio of incident and the reflected voltage waves, and second one, the device used to get the measurement of S parameters of n-port microwave network is network analyzer. Then third one, that is scattering matrix for the lossless matrix is, that is unitary matrix, and for a simple admittance Y, the ABCD parameters are A equal to 1, B equal to 0, and C equal to Y, and D is equal to 1. Then finally we conclude that in this session we come to know the S matrix representation of multi-port network and a two-port network analysis for the S parameters and different types of losses and properties of S matrix. Thank you.